All right, so the first one that said to simplify. How do I simplify that? How do I simplify this fraction over here? Divide by 2. What am I dividing by 2? Just the x? So we want to take this guy on the bottom, and it's going to distribute to each of these pieces. We're using the distributive property, but with division instead of with multiplication. So 2x divided by 2 plus 6 divided by 2. What happens here when I do 2x divided by 2? I get just x. Bring down my addition sign. What about 6 divided by 2?
3.
I get 3. So x plus 3 would be my fully simplified answer here. Right. That's one of the skills that we're going to be making use of. That is division. It's not long division, but it is division. Then I asked you guys to practice with long division. I have a single digit number out here, and I am dividing a triple digit number. What's the first thing you want to look at and ask yourself? How many times can 3 go into this first number? How many times can 3 go into 4? 1 whole time. So I put that up on top, and then what do? I do 3 times 1, right? 3 times 1 is 3, and now I subtract that. What is 4 minus 3? 1. Can 3 go into that at all? No. That's how I know for sure that I got as many up on top as I needed to. And then I'm going to bring these other 2 numbers down. I know that 3 can't go into this first number, so what do I look at? I look at the first and the second number together, right? How many times can 3 go into 19? 6 times. So then I take this 6 and I multiply it to the 3. 6 times 3 is 18. And then what do? Subtract it. The 1's cancel out. 9 minus 8? 1. And then I bring this 3 down. How many times can 3 go into 13? 4 times. So then I have 4 times 3, which gives me 12. Then what do? Subtract again. Every time after I multiply and write it down below, I'm subtracting. What is 13 minus 12? 1. What do we call it when we have a leftover piece like this? I'll give you a hint. It starts with an R. Remainder. The piece up on top we call our quotient. And I can take this number and I can write it as a mixed number. I have 164. And then I had a leftover remainder of 1, but it's 1 that's supposed to be divided by this piece outside. So 1 over what? 1 over 3. So 164 and 1/3, which most of the time we just see written like this. We leave out the word and. But when we read it back, we say 164 and 1/3. So far, so good? We're going to be making use of this skill a lot today, too. What's a mathematical operation that we normally use when we see this word and? Addition. So I could even say 164 plus 1/3. Those all have the exact same meaning. In your books today, let's go to page 241. Yesterday we talked about multiplying. Today, tomorrow, Friday, we're going to practice with division. We're going to spend a couple days on this because we need to practice with these skills just from the number of people that I heard say around the room, man, I haven't done long division in a long time. It's part of the reason that we're going to spend some extra time on division here. To divide a polynomial by a monomial, monomials have how many terms? One term. This is like the Bellwork problem where I had the 2 in the denominator. To divide a polynomial by a monomial, we're going to find the quotient of each term. We are distributing to each term in our numerator. And so I'm going to write them each down as their own division problems. If it's subtraction in between, I'm going to write it down with subtraction in between here. If it's addition, then I'll write it down with addition. And then I simplify each one. And so like this one comes out to be 2x minus 5. That's the first skill that we're going to practice on example number 1 today. We can also divide a polynomial by another polynomial that has more than one term using a process that is similar to long division, which is why we practice that on your Bellwork. You guys ready? All right. Let's look at example number 1, page 242, so next page. First thing I want to talk to you about is this notation. How many polynomials do I have here? 2. This is a polynomial that has how many terms? 3. So this is a trinomial. And what about this guy then? That's a monomial. Do you see that -1 where the exponent belongs? That means put it on the bottom of the fraction. Negative exponent equals move to the bottom of a fraction. All right, so I want to do that. I've got my trinomial up here on top. What should I put on the bottom? 6ab should go on the bottom of my fraction. Yes, ma'am.
Would you still move it if the exponent was positive?
If the exponent was a positive, I would not move it, and in that case, I would not be dividing. I'd be multiplying there. So if it was a positive exponent, I'd want to multiply these together. If it's a negative exponent, I move it down to the bottom of the fraction, and that's how I know it's telling me about division. You guys told me this was a monomial. How do we divide with a monomial? Distribute to each term. So I'm going to distribute it here, and here, and here. That's what we've got written down here. There's my first term over my monomial. And then we've got our second term over our monomial. And finally, we have our third term over the same monomial. And now we need to simplify each one of these fractions. So I'm going to look at the numbers, and I'm going to look at the variables separately. So I'm looking first at the 24 and the 6. Can I reduce that at all? Is there anything that goes into both of those? 3 goes into both of them. Anything bigger? 6 goes into both of them. What is 24 divided by 6? 4. And then I'm going to come over here and I'm going to look at the A's. Are there more on top or more on bottom? More on top. What does it mean to say a to the 4th again? What does that exponent of 4 mean? Multiplies by itself 4 times, right? And I've got 1 on the bottom. If I have something the same on the top and bottom, like 2 divided by 2, what happens? It cancels. So 2 divided by 2 would cancel. I can do the same thing with my variables. One of those a's is going to cancel. So I have how many left? 3. So that would be a to the 3rd power. And then I'm going to look at the b's. Something kind of similar going on with the b's. How many are in the numerator?
2.
Currently?
Oh.
3. B cubed, so b times b times b. And we've got just 1 down in the denominator, so when I simplify that, one of them cancels out and I'm left with what? B squared, because they're multiplied. All right, so this is how my first term simplifies. And then I bring down my addition sign, make a little bit more room here. So I bring down that plus, and then I repeat the process here. Can 6 go into 18?
Yes.
How many times? 3 times. So I have the whole number of 3. If it can't go in a whole number of times, I look to see if I can reduce it. But this goes in a whole number of times. What about those a's? I have a squared on top and just an a on the bottom. A times a over a, what's going to happen? One of them cancels. So I've got how many left? 1a. What about b? Same exact thing here. So I've got a single b here. I'm done with that one, so I'm going to bring down this sign. This one's a subtraction this time. And then I'm going to come to the last fraction. Can 6 go into 30? How many times? 5 times. What happens with my a's? They cancel. I only have 1 on top and 1 on bottom. And then with the b's, I have 3 on the top and 1 on the bottom. So what's going to happen? One of them cancels out, and so I have what as part of this term then? B squared. That is my final answer. So far, so good? Let's try some of that long division stuff. Look at example number 2, still page 242. Example number 2. Whatever comes after my division sign, this goes on the outside. This is what I'm going to divide it by. This would be the same as the bottom of the fraction. So when I'm writing down my long division, this guy goes out here. On the bell work, when I had 3 on the outside and 493 under here, Chase, what did you tell me that first step was?
The long division?
On our long division from the bell work?
See how many times the first number can go into that can go into the
Yep.
first number.
See how many times this can go into the first number. That's exactly what I'm going to do here. I'm going to see how many times x can go into x squared. So if I set up a little division problem off to the side, x squared on top, x on bottom, will this reduce or simplify at all?
Yeah, just a X.
I'm going to have just an x, because that's the same as x times x over x. One of those will cancel. this is what I'm going to put up on top. I'm going to put it over here because this is an x squared. That's not x squared. I'm lining up my like terms here. Now I'm going to take that x and I'm going to distribute it to both pieces here in the front. What is x times x? X squared. What is x times 4? 4x. Notice I'm lining up my like terms when I write it down underneath. All right, Chase, I'm going to need your help again. Looking back to the long division that we did on the bell work, I took and I multiplied, I wrote it down here. What did we do after that? Subtract. Here I just had one thing to subtract, right? How many things do I have over here? I have to subtract both of them. So I'm going to subtract this one and subtract this one. What is x squared minus x squared? Cancels out. Goes to a 0, cancels out. What happens when I combine negative 5x and negative 4x together? Negative 9x. What should I do now? Bring down that minus 36. So I'm going to catch up over here with where we were on the bell work. I had a 1. We brought this down. What did we do on the bell work when we got to this point after we brought things down? We did it all again, right? Yes. How many times can 3 go into 19? In this case, I want to know how many times can x go into negative 9x. So I can always pull that off to the side and do a little division problem here because this will tell me how many times it'll go in. I want to know what to put up on top. I'm trying to figure out how many times this goes into this. So I'm pulling it off to the side. I'm taking this and it's going up on top. And this is going on bottom. Because if I can do this, whatever number I get from that, or numbers and letters, that's what I put up on top. What would happen here? X's are going to cancel, and I'm left with what? Negative 9. This is what I'm going to put up on top now. What do you think I need to do with that negative 9? I need to distribute it just like I did with the x. I'm going to distribute it to the pieces out in front. Both parts. Negative 9 times x gives me negative 9x. Negative 9 times 4 gives me negative 36. So just like before, I got 2 pieces. Oh, thank you. I said 6 and I wrote 9. That's the second time I've done that. Thank you. I had 2 pieces before, and then what did we say we had to do to both of those pieces? Subtract them. Here I got 2 pieces. What do I need to do with both of those? Subtract them, but they already have minuses. What happens when I subtract something that's already a negative? Turns into addition. When we do this, after we distribute, we will change. Whatever the signs are, we're going to change them. What is negative 9x combined with a positive 9x? Cancels out, gives me a 0. What about negative 36 combined with positive 36? That gives me a 0. Which piece is my quotient? Yes, that piece up on top, x minus 9, is my quotient. What's my remainder? 0. Here's my remainder. Let's do one more problem together, practicing that long division. We'll get some more practice in with it tomorrow and Friday as well. All right, so this time they wrote it for me as a division problem. Notice the bottom goes where? Bottom goes on the outside. First question I want to ask myself is, how many times does this first piece go into this first piece? I tend to pull these off to the side. This came from the top, right? So 3z cubed. This piece came from the bottom. Can I simplify that at all? What would it give me if I divide those two pieces? 3z squared. This is what I'm going to put up on the top now. 3z squared. Once I get that piece that goes up on the top, Dwayne, you got to stay with me. What do I do with that now? Multiply. I'm going to distribute that to how many things? Both of these pieces out here. 3z squared gets distributed to both pieces. What is 3z squared times z? 3z cubed. What is 3z squared times negative 5? Negative 15z squared. Okay, I distributed. Now what do I do to both of those? Subtract them. So I put a minus here. That one already had a minus. When I subtract something that already has a minus, it turns to a positive. Copy, change, change. We're going to change both of our signs. What happens to my 3z squared here when I combine it? It cancels out. That should always be happening. What about negative 14z squared when I combine that with 15z squared? 1. I'm going to have just 1z squared. And then I bring these other two guys down. What do I do now? What do I do now? I'm going to start this process all over again. Remember how I wanted to know how many times z went into this? Once I bring things down, I'm going to ask myself the same question again. How many times can z go into z squared, this front piece right here? So z squared is up on the top. Z is on the bottom. How many times can z go into z squared? 1z times. This goes up on the top. Is that a positive or a negative? So I'm going to put plus. All right, I did that. What next? Multiply. I take that and I distribute it to both of the pieces out in the front here. Z times z? Z squared. Z times negative 5. Negative 5z. All right, I distributed. What do I do to both of them now? Subtract them. This one's easy, but when I subtract something that's already a negative, it turns into addition. What happens to my z squareds here? They cancel. Negative 7z combined with 5z. Negative 2z. Bring down my plus 3. After I bring something down, what do? Start all over. How many times can z go into negative 2z? Negative 2z, z, negative 2 times. These are going to cancel. And I'm left with negative 2 or minus 2. That goes up on the top. All right, I wrote it down. What do I do with it now? Multiply. Distribute it to both pieces out at the front here. What is negative 2 times z? Negative 2z. What about negative 2 times negative 5? Positive 10. What do I do to both of these pieces? Subtract them. That one's already a negative, though. So it turns into addition. This one becomes a minus. We change both signs. We're always going to change the signs after we distribute. What happens with my z's? They cancel. 3 combined together with negative 10. Negative 7. Yes. I wrote a positive, but then remember, we're changing both of our signs every time. So it started off as a positive 10, and then we changed our signs. Yep. Good question. Does z go into this at all? So what would I call this then?
Remainder.
That's my remainder. What do I call the piece up on top? The quotient. So the way I would write my final answer for this, I write my quotient first. 3z squared plus z minus 2. And then I need my remainder, but the remainder is still part of a fraction. Remember on the bell work when I had that remainder? I had a remainder of 1 and I had to put it over this piece. I have to take this remainder and put it over this. So it's going to be minus 7 over z minus 5. Minus here because the 7 was a negative. If it was a positive remainder, I would have a plus. So here's my quotient. And here's my remainder. So far, so good? That is where we are stopping for today. Your homework. Dividing by a monomial, that's these two right here. And this one right here. So there's 3 practice problems where you're dividing by a monomial. And then give each of these a try. If you do that over the next 3 days, you should be able to get all the homework done and not have to take any home over the weekend.